Beyond the Hood, stories and strategies to fuel dealer growth.
Welcome everyone to Beyond the Hood with TractorZoom. I'm your host, Andy Campbell. Today our guest is Hank Mandsager, lead data scientist here at TractorZoom. Hank is responsible for leveraging artificial intelligence and machine learning to uncover insights and help TractorZoom's customers make faster and better decisions. In our conversation, Hank and I will tackle one of the most common questions we've been receiving here lately at TractorZoom. How will AI and data science influence our equipment dealership industry? Now, unpacking this question leads us into defining what is quality data, as well as what is AI and its potential for dealerships. Hank has experience implementing AI and data science models to solve problems in multiple industries, and he walks me through a few examples of how you and your team can do just that for your dealership. Now, Hank describes his work experience way better than I could, but I'll give you a spoiler. It involves testing fighter jets for the Air Force. With that, how about you join me as we look beyond the hood at the future of AI for equipment dealers with Hank Mandsager. Hank, welcome to Beyond the Hood.
Thanks. I'm happy to be here.
Good. Well, I'm going to get into going through the introductions, and I'm going to have you describe a little bit of your background. It's super unique, but I want to start big. And in one of the recent webinars that we did, we asked all the audience members just one question about what do you want to learn about the most? And the number one answer by far was AI and how AI might impact farm equipment dealerships. So I'm going to just toss that one to you to begin with. And what's your thought on the impact that AI might have on farm equipment dealerships?
Well, AI is definitely the thing everybody's talking about right now. It's affecting every industry, bottom to top, and pretty much revolutionizing the way we work, not unlike kind of computers back in the 90s. So in that sense, there's a tremendous opportunity in dealerships across the country in terms of leveraging AI. They can use it in marketing, sales, parts and services, really everything under the sun AI can help with. The real thing that dealerships have to understand is it's not the silver bullet. It's a tool like anything else. And so it's more of how they apply it to their business and why they apply it, and then the processes that they develop that's going to be critical. But really, there's a ton of opportunity for dealerships to adopt AI across the board.
Okay, and good. And so this, revolutionary AI, and I'm going to ask you in a second about what is AI, what is machine learning, all those, all those keywords now that we're tossing around. But let's give you a little credence here and give you a chance. You're wearing a F-22 shirt. It's not just some random one you bought off of Goodwill. So how about you give the audience a little bit of background about yourself?
Sure. So my background is a little unique, particularly I'm a data scientist now at TractorZoom, but I didn't start that way. So I actually went to college and I studied aerospace engineering. So pretty early on, I caught the aircraft bug. My uncle's in the Navy, and I had a chance to go on the USS Enterprise actually for a 3-day cruise. Wow. So I flew down, and then we got a sail from Jacksonville to Norfolk. And during that cruise, we got to see them land, take off. They dropped bombs in the ocean. They did F-14 supersonic flyby deck level. So immediately I was hooked. So 5th grade on, I was like, this is what I want to do. This is it.
I can skip that whole, what was one moment in your childhood that transformed you?
Yes, it was that. And it still sticks with me. Still get it, you have the smell of the aviation fuel and the rubber from the deck and the feeling of a sonic boom that's just half a mile away, and
I can't quite tell you what that feels like.
It feels like your chest is cavitating almost. It knocks the wind out of you, and it was an incredible moment. And so from that moment on, I was like, that's what I'm studying. That's what I'm going to school for. And so I did an undergrad out west, Cal Poly San Luis Obispo, and studied aerospace engineering with a focus on aeronautics. And really, my background in school was really on the aerodynamics piece. So I did a lot of computational fluid dynamics, which is CFD. And so that's where I kind of got this data bug. I did a lot of coding, a lot of programming during school to really build out these airflow simulations. And then the first job I took out of school was actually with the Air Force. So I was civilian, I never wore the uniform, didn't have to serve, but I had the opportunity of working on fighter jets, which was awesome. So I was a flying qualities engineer, which really is the focus of how does aircraft perform? How well does it fly from a pilot's perspective? Air data, a little bit of propulsion, so it kind of ties that all together into, this is a flying machine and how well does it do that. I had the opportunity to work on the F-35 program for 3 years, which is really cool. So when I started, it was still in development. By the time I was leaving it, they were actually fielding it for service use. Was able to get on a program called the F-35 drag chute. where I really got to kind of cut my teeth as an engineer, as like a project leader. And so that was a program specifically for our Norwegian partners, where they would actually deploy a drag chute on landing, for the icy runways up north. So got to travel to Alaska, do icy runway testing, got all sorts of really cool experiences, got to travel to Norway, give presentations to their MOD, Ministry of Defense. And that was just really great exposure for me to just say, like, okay, I really like these big projects where we're kind of thinking big picture, but also a ton of value there in terms of being able to provide one of our strategic partners, critical capability. The Russians are operating up in the Arctic. Now we can too, and we can do it with F-35.
So, and on that, back up, prior to even you, joining into this, how did they test fighter jets before there was data science, before there was this modeling?
So that was actually a pretty revolutionary shift about when I was there, and maybe a little bit before. It was essentially going and flying at every single point in the envelope and just saying, okay, I hope we're good. And it was really dangerous. There's a lot of discontinuities, or basically like cliffs, essentially, that you don't know where they are until you kind of look over. So you hope that you can kind of build up slowly so you can see that there's a cliff there before you get off, but sometimes you didn't. But modeling and simulation and that data aspect of it allowed them to have a really good understanding of how the aircraft will perform before flight test. So a lot of what we were doing is really just validating that simulation, which cut down drastically on the amount of flight tests we had to do, kept pilots safer because we knew what to expect. So flight test is a lot different now than it was like Chuck Yeager days, back, the right stuff where, So the base I worked at, Edwards Air Force Base, every road is named after a pilot that has passed. And there are a lot of roads at Edwards Air Force Base. So it was one of those things where you kind of are always stuck with, this is a pretty serious business that we're doing, but the technology, the progression we've made in terms of data science, modeling, and simulations really made it more of less of a cowboy kind of gung-ho approach, and it was very technically driven, really data driven.
Well, so, and I imagine we're going to draw some parallels from that into the farm equipment world here in a little bit. So once you've left the, California, essentially, you did make your way back to the Midwest, right?
Yep. So, when F-35, when F-22, that's where I really caught the data bug. So F-22, we were doing a lot of really big data projects. And me and my wife were both from the Midwest, so we wanted to get back and be closer to family. So this was where I was like, this is, I think, a career I can transition into so that I can, find enjoyable work in the Midwest, because I knew I couldn't do.
Right. Yeah, we don't have test pilots out here.
Yeah, I wouldn't be working on airplanes here, or at least not any interesting ones. So I ended up working for a Midwest retailer as a data engineer. That was my first job, kind of changing careers, and that was tough. That was a big transition, just getting like out of a space where I'd been in for 7 years with undergrad and really understanding aerospace, and getting just all the way into data at an enterprise level. But it was great growth opportunity. Obviously, a retailer has just millions and millions of transactions a day. There's just so much data about customers that I was able to learn a lot on the big data space, transitioning into data science as well there, and building out models for predicting the best place to build gas stations, for example, and what's the best way to stock a shelf, like how many units should be on each shelf based on demand, based on profitability, things like that. So there's a ton of opportunity for me to learn and grow. But then, Tractor Zoom came calling, and I had only worked at enormous organizations over the course of my career, so I thought it'd be a pretty cool opportunity to work for, startup and work for a small company.
Right. Because I know that, not only are you working with the engineering staff here, and you're working with myself and the rest of the marketing team, customer service, but you're also out there, you've gone to dealerships, right? And then sat down with, whether it's their data people or just listened to their story. So tell me about that, how that has been different from certainly from the Air Force, but also from, retail.
Yeah, so retail, everybody's a customer. Everybody needs to buy groceries, right? But here, I get to learn so much from the customer that I didn't know. So I grew up in Iowa, but I didn't grow up in the ag space. So I feel like I learned so much about the world that I grew up in, but I never knew, which has been really, really cool. But also, I feel like we're solving their problems directly. So I feel like there's a lot of appreciation for the work we're doing, because we're going there, we're listening, and we're saying, okay, I understand, here's your problem, here's a solution we can build for you. And then actually getting to work with them throughout that entire process has been really rewarding.
Okay. And so you had mentioned, building solutions and working alongside people. So I'm going to actually jump ahead from a couple questions that I had planned, because I know you've worked on a couple really interesting projects here that have made a difference within dealerships. And some, for me, they're all heavy lifts, but for you, I think some are more difficult than others.
Yeah.
Do you want to just talk about a couple of the projects that you've worked on with dealers and what the results of those have been?
Yeah, so one of the things, maybe big picture too, is when people think data, I think a lot of people think maybe like Excel spreadsheets. So that's what we would call tabular data, structured data. It has a row and it has a column. But one of the areas that I think remains untapped in our industry is the unstructured data. So that would be things like text, that could be things like voice, but pictures is one that I think remains really untapped and has a ton of potential for us. So one of the projects that I just went and said, hey, let's see if this works, is I wanted to create a model that would tell you whether your listing image was a good image or a bad image. You have some dealerships, you have some auctioneers that do a great job of really marketing the equipment that they're selling. It looks great, it looks clean, it looks like they take care of it. And others, maybe less so. And it was really just how much does that impact the overall sale value of equipment? So I ran these sort of models for different customers and said, hey, these lots, maybe you have 8. They're like, hey, these pictures aren't that great. Here's ones that are really good. Here's that are missing images. And we've had customers come back and say like, hey, we changed our entire procedure on how we take pictures to make sure that they're all matching our branding so that when people see equipment from us, they know it's high quality. And others said, this has been part of updating processes so we don't equipment doesn't fall through the cracks. Pictures are taken, after it's been cleaned and serviced versus before so that we can make sure we maintain that, professional image. And for me, that it wasn't a super difficult lift from a technical point of view, but just understanding how the customers would use that information was really powerful and was a really cool opportunity. I think you can go big picture though and talk about generative AI, and we've built some generative AI stuff here too, and that was 6 months of work, but you get really, really big impact because it affects everyone, right? And it's not just, hey, go take some additional pictures. It'd be like every piece of equipment that's coming across our database now has double the amount of attributes because we're using generative AI. So it's always one of those things where I love building things quickly just to get reaction and figure out what works, but also those big impact projects are really rewarding.
And I want to get into that generative AI project here in a second too, because not only is the result of that project really cool, but it's also the process you took to go about doing it. And you, like you said, you started fast and just kind of almost fast and messy just to see, does this thing work? And so I want to get into that a little bit because it's not only a lesson learned in AI, but it's also a lesson learned in building things, and a process to go through. Before we do that, though, I realized I didn't hit on some of the technicalities on AI, on deep learning, on machine learning, all that kind of stuff. So let's just go through really quick. AI, artificial intelligence. Yeah. What does that definition mean to you?
Artificial intelligence is just someone else making a probability, a decision for you. Maybe decision is not quite the right word. It makes a prediction. Mm-hmm. That's what it means to me. I think there's probably broader definitions that are more applicable to other spaces. So AI is this big bubble, and within AI you have machine learning. So machine learning is AI, but AI might be more than just machine learning. I generally just deal with machine learning piece of it, which is to essentially say I'm teaching a computer to think, and once it sees something new, it can make a decision or a prediction based on that new piece of information. As long as that new information looks close to information as learned from. It's not too different from how we learn, it's just at a much simpler scale. I think there's a lot of nuance and people kind of have opinions either way, but if you just think AI is this big picture of machines making decisions, making predictions, and then machine learning is actually teaching those machines, to learn from new information.
Okay, and that's a good distinction because I know you and I have had conversations on how do dealerships start? What do they need at a base level? And then what do they need beyond that? But understanding what is machine learning also helps one person kind of understand what's capable, what's possible within this.
And I think the big thing to keep in mind is that machine learning, it can't predict something completely novel. And so the coronavirus pandemic is a great example. No one's models had any account for what happens with a once in a century global pandemic. Because that doesn't happen. We don't have data on that. You could simulate it and you can guess and things like that, but no machine learning model would be able to know because it wouldn't have data on it. Same thing with interest rates sort of right now. The last time we've seen interest rates as high was 20, 30 years ago. So most businesses, maybe outside banks and other financial institutions that have been around for a while, they don't really have data on how does this business operate in a high interest environment. So the fundamental thing people should understand is that you need to have data and it needs to be representative of the future you're trying to predict for. which it's difficult to understand, and sometimes that makes it not as useful. If you're trying to say like, well, I want to know what happens in 10 years, like, good luck, sort of thing. But like if you want to say, I want to make a decision today, and it's roughly the same as sort of things I was doing, and I want to do it at scale, and I want to be able to surface these predictions across my business, that's where you can get a ton of value.
Huh. Okay. Good. Well, then, keeping on the farm equipment side here, what are some key challenges then that dealerships might face when they're trying to implement, call it big data science within their dealership?
I think the first thing that a dealership should do before even thinking about AI, about machine learning, is just go and have an honest evaluation of, do you have data? Because you can't do anything without it. It's oil. If you don't have gas, you're not going anywhere, that sort of thing. So are you recording it? Is it documented somewhere? Hopefully digitally. Do people have access to it, or is it locked down in some other system? So do that kind of evaluation of, do you have a lot of data? And what is that data? What do you have data on? Do you have data on your customers? Do you have data on the machines that you're selling? Do you have data on your parts and services department? Because all of that information will kind of dictate where AI could play a role.
On that, because I've talked to a lot of our customers that, yes, they've got data, and then I open up the sheets that they have, the exports and everything, and then you look at the data and the cleanliness, and I know, like, man, I don't know if I personally can even work through this. So that gets into the data quality piece.
Data quality is huge. There's a saying, garbage in, garbage out. So if you've got bad data feeding your models, you can have bad predictions coming out of your models. And the effects can be kind of insidious. Like, it's not always obvious how bad the predictions are until you get down the road and be like, okay, we've been underselling our equipment, under-evaluating our equipment for 6 months, and we just realized it. So how much profitability do we just throw away? Because maybe it's 1% here or 1% there, but over time, that makes a big difference. So data quality is the most important thing. In my opinion, it's the most important thing to making a successful machine learning model, and then therefore actually getting adoption. Because if the model's not any good, no one's going to use it, and it's not going to have any adoption. So data quality is a really difficult thing to kind of assess until you have some experience. So if you're in that boat, you're like, I think I have data, bring on a third party, talk to a vendor, just meet with somebody who has more experience in the data space than you, and then they can try and help evaluate that data for you, whether or not it's ready for machine learning. And maybe it's not, but maybe there's still useful information that can be teased out of it. Maybe there's some insights, maybe there's some analytics they can run, and they can still get some value out of the data. But there's also just the effort of like cleaning it.
Right.
The time, the money, the sweat equity really to make it useful is worth it. But you just need to know what the goal is once you actually have that clean data.
Okay. And then one last thing on clean data before we kind of get to some of the other challenges. You told me something about 110, 100.
Yeah.
Okay. Do you want to elaborate on that?
Yeah. So the way I explain data quality, and the reason we spend so much time at TractorZoom making sure that our data is as clean as possible, is you sort of have a consequence ladder. It costs $1 to clean the data. It costs $10 to clean the data once it's already in your system. And it costs $100 to do nothing about it. And that really just highlights the effect of having bad data on your models, getting bad predictions out, and then having a cascading effect of lack of trust, poor performance, things like that. Once it's in the system, it can have its tentacles in a bunch of different ways. Different systems might reference that data in different ways, and it's really hard to kind of pick it apart and find all the ways that it kind of moves through your systems. And so that's why it takes 10 times as long to really clean it once it's got its talons in. So the upfront effort of cleaning your data before it gets into your system is 100% worth it.
Okay. So main takeaway, even from this entire podcast, clean that data.
Yes.
Make sure have the processes set up so that flows in the purest form possible.
Yep. And so once you have that clean data, and you as an organization have the strategy of saying, we want to be a data-driven organization, we want to leverage our data to drive value, you're going to have to put that upfront work in. But once you have the clean data, you still got a lot of challenges in front of you.
Okay.
And so I kind of group those challenges into 3 different categories. I would say technology is one, culture is another, and then processes. Technology is honestly is the easiest thing to solve, because you can always buy something. You can work with a partner, or you can buy a software solution, and you can sort of have some of these data products available to you. The big decision you're really going to have to make on a technology front is, are you going to build it yourself or are you going to buy it? My advice on that decision is data going to be the key differentiator for your business? It's the thing that separates you from everyone else, is your ability to analyze and leverage your data. For most dealerships, that's probably not the key differentiator, but if it is, then you probably want to start bringing some of that capability in-house. You want to hire the right people that know how to clean the data, make it available, analyze the data, build models. You would want some of that in-house. If you're thinking, I want data to drive value for me, but it isn't my key differentiator, I want to just make sure I'm using data to be as efficient as possible, then start looking for third parties or partners or other vendors to help get you there. But that's definitely the easiest one kind of to solve.
Okay. So then out of culture and what was it? Culture and processes.
Yeah.
Okay. What's the next?
So culture and processes kind of go hand in hand, and they all sort of overlap. Technology involves people, culture involves people, processes involve people. Always people at the end of the day. I would say culture is the most difficult, and then I would say process is a little bit easier. The challenge with processes, and where it might bleed over to culture, is that AI really transforms who makes decisions. Decisions always get made, but in a machine learning model, it's the person building the model at the end of the day that made the decision, because they designed the model to act in a certain way and to provide certain predictions. So say someone, you always had a marketer that decided where you would spend your marketing dollars. Well, those decisions might get translated into an AI model. And so that's part of building out your processes, is who's involved and where are they involved, and making sure that processes allow for those decisions to be made. But then it bleeds heavily over into culture, where you're saying, hey, those decisions won't be made by this person anymore. They'll be made at this model level. And that person will review and oversee the model, but most of the decisions will be flowing through the model. So one way the glass half full is, it relieves that bottleneck of a single person making all of these decisions. And so now we can do more. But then the glass half full is, hey, it's taking my job. So that's where it becomes really difficult from a culture perspective, is people have to understand the why. AI is never going to take your job. Not at these places. It's never going to sell equipment. There's always going to be someone selling equipment, and it's not going to fix the equipment for you. There's going to be a technician fixing the equipment. We should view AI as more of a tool in the tool chest. And so it just becomes incumbent upon the people who are actually driving that AI and data change at a dealership to make sure that that's clear in the strategy.
Right. And I think with a lot of dealerships out there too, that's, I think, a knee-jerk reaction of, do I want it to take my job? That might slow adoption. But I don't know of any dealership across the country right now that's saying, man, I have too many people to choose from. Yes. My labor force is oversaturated. Nobody's dealing with that problem. And I don't think demographically we will deal with that.
I think it's a unique industry in that they tend to be in smaller communities, rural communities that are shrinking. And that also it's a skill set, like my generation, the number of kids that grew up on farms is so much smaller than the previous generation.
Right.
We just don't have the exposure to agriculture that previous generations did. So you're right, the talent pool is going to be way smaller, and you're always going to be looking for the best salespeople, the best technicians, and there's just not enough of them to go around. So how can we use AI to fill some of those gaps? So your techs are doing all the things that make them really valuable. They're working on equipment, they're doing the things they enjoy, and use AI to help augment anything that they don't want to do or anything that's not as valuable for them to be doing.
Hey everybody, Andy here. I want to take a moment to ask you to subscribe and follow this podcast just so you don't miss out on all the latest updates and insights for your dealership. Now, let's get back to this conversation. Okay, and then on the technician thing, and we're probably going to stick this in a bottle and then take it off the shelf here in a little bit, because I know you and I had brainstormed before about how could AI help X within a dealership, and we talked about technicians. Yeah. And I think there's some really cool things that you can do, tomorrow to help technicians. But let's get to that one in a second. We talked about building AI, and so if dealerships from a strategic high level want to say, okay, I want to make this our thing. I want to leverage data better. And they might not be, ones that make it their competitive advantage, but they want to make better decisions on it. And most dealers are fitting into that bucket. What advice would you have for them to kind of building this thing out? And then I think from that, we can kind of mirror into how did you build out a generative AI model?
Yeah. So I think we talked about the data quality, making sure that your house is in order on the data front. You might need help with that, bring in partners, but get to that base level of where you trust your data, essentially. And then from there, I'd start looking at problems that are rules. And so what I mean by that is we all have rules that simplify our life. So, maybe it's for me, hey, I won't drive if there's a blizzard warning. Just a rule. Because otherwise I've got to go and think, hey, if I drive my car today, normally there's a 1 in 100,000 chance I get in a car accident. But when it's a little bit snowy, maybe it's 1 in 1,000. But maybe if it's really snowy, it's now 1 in 100. And we don't do that. Like, people don't think like that. We just make rules. Businesses do too. A rule might be, hey, if we quoted equipment and then if it's been 30 days, it's no longer a valid quote anymore. That's just a rule. AI could say, okay, I'll tell you when that's no longer a valid quote, or I'll update it automatically for you. We don't have to have these rules anymore that we just use to simplify our life. Start thinking about, like, what are things where we're making decisions subconsciously or just through these rules, but where a prediction about the future would be really valuable. Start listing them out. Creating a value effort chart, saying, hey, this is going to be the highest value thing for me is if I get my people not thinking about this, or hey, every time we evaluate equipment, we essentially say, like, add 15% just for margin, or add 5%, whatever the number is. Well, what if we give you the right number? What if I tell you exactly what that margin should be so that you can sell the piece of equipment in the time frame you want? Those are the things that kind of get the brain churning. And then obviously it becomes from there a sort of understanding the cost and the time. So you'll definitely want to get quick wins. You'll want to go identify that low-hanging fruit that you're like, hey, if we do this, we bring on a team, 6 months, we've got an answer. And we're pretty confident that it'll work. Those are the sorts of ones you want to start getting, because that's going to help the culture piece. It's going to get buy-in. If you say, I want to bite the whole apple, I want to take everything and do it all at once, and it's going to take 3 years, everyone's going to be jumping off the train at some point. Like, they're like, I'm tired of this. I don't want to do this. I don't see any value in it. So really targeting value, but focusing on what you can do short term, for sure. That would be probably the key. Is everyone has this, like, I want to go summit Mount Everest. I want to do the biggest thing possible because that's cool and fun to talk about. But it's just, you have to drag the whole company across with you.
Right. And you have to have funding with it too. I mean,
100%.
And one of the benefits of quick wins is culture, like you had mentioned. And it's also management buy-in too, saying, like, I think this is a possibility. Prove to the people that it's a possibility, but also prove to management and the dollars that this is worth future investment.
100%. So if you're not at that executive table, so when I was talking, I was thinking more from the executive perspective. But if you're not there and you're really trying to get that executive buy-in, 100%. Go small. What can you do with one person? What can you do in a couple of weeks, and build those proofs of concept just to say, like, hey, this works. I think if we put more money behind it, put more manpower behind it, we can make it something. So those are the things I look at TractorZoom too, because there's just one of me. So I've got to make sure I'm focusing my time on the most important things, which means I am trying things constantly and failing fast. And if I fail, put it on the shelf, try something else, because I don't have time to kind of work through all those problems. I don't have the resources to do it. So particularly if you're coming at this from, like, I'm in a dealership, maybe I'm mid-level, maybe I'm low-level, but I'm trying to become more data-driven, go identify those things that you can do on your own, or maybe just one other person, just kind of fly under the radar, keep things small. And then once it works, or you found something that works, then take that up and elevate it with management.
Okay. So you had mentioned failing fast. And so this is a great segue into what you've developed here at TractorZoom, within TractorZoom AI, or TZAI. And we call it smart descriptions. And that's what it's labeled on TractorZoom Pro. But the approach that you took was that, you're a one-man data science team right now, and you had to learn to fail fast, or to fail and learn and continue. So, just to help frame up this process that one could go through, and this is a success story, talk about how you approached, we didn't call it, smart descriptions from the beginning, but this frame that we now call smart descriptions. Talk about that project, how it started. I know you did Chat GPT a little bit from the beginning, and then what that has progressed to today.
Yeah, so I think you're hitting on one thing too, that failure isn't bad. If you're not failing, that means you're not trying difficult things. So just for everyone's perspective, I'm happy if I'm successful 70% of the time in data science. I fail a decent amount. And it doesn't scare me, and it's fine. I won't lose my job over it, because that's what you have to do if you want to keep pushing the boundaries. So when I fail, I make sure that failure is as least painful as possible. If I'm going to fail, I want to fail immediately. And so what I do is I tend to set up projects that have gates or checkpoints. So I'm saying I want to just go explore. At the end of that exploration, I need to be here. If I'm not at that point, I'm done. And so for smart descriptions, what I said is I wanted to take ChatGPT, just off the shelf, anyone can access it. I wanted to feed it an equipment description, and I wanted it to return back to me all the useful, important features on that. So for a tractor, it might say, hey, it's got a loader, it's got this many hours, it's got a mid-mount mower, and no cab. But from that description, can it point out those 4 pieces of information and return it in a useful format for me? And so I did that for a few days, maybe a week, and just said, okay, I can kind of teach it a little bit, and it's off the shelf. It's figuring it out. It knows equipment probably better than any new person just coming into TractorZoom. So the example I always give is it knew without any prompting that SEV was hydraulic. It knew that acronym. It had seen it somewhere and knew. So I was like, I think this is something that will be useful. I didn't know exactly what, but I was able to hit that checkpoint of saying, I gave an equipment description and it pulled out useful features. It wasn't perfect, it wasn't always right, but it was better than I had thought. And honestly, it was approaching that level that you get from humans. I knew it could be, and I hadn't trained it, I hadn't done anything special. Anyone could have done this, just off the shelf. And so what I wanted to do from there is I wanted to say, okay, I want to fine tune it. I want to see what can I do to make it better. Give it the same set of data, but now I'll teach it. And that took a little bit of my time. So that's where being a one-man show kind of stinks, is like I had to build a data set for it to learn from. And that took a week or two. But I built this data set and I said, when you see a description that looks like this, return, this. And from there, it got even better. So I noticed a pretty significant improvement from just off the shelf to this really small fine-tuning example. Just looking at tractors, just looking at 40 examples, it quickly picked up what it was supposed to be doing. So like, okay, I feel pretty confident if I 10x this, 400 tractors, it's going to be even better. And so that was going from checkpoint 2 to checkpoint 3. I was like, all right, went to the CEO and said, I've got an idea. Here's why I think it works. We're going to need some money. We're going to need some time. But I want to make sure that this is the most valuable thing for TractorZoom. Here's all the reasons why I think it will work. And that's where we probably started from what most organizations say, like, the project start. But I had already done enough background to say, like, I think this is relatively low risk.
Yep. And then the event, when you're having that conversation with our CEO, Kyle, you're also talking about what is that end game too, right? Like, what are we actually trying to solve with this?
Right. And so at TractorZoom, data's our lifeblood. That's what we do. And so really the goal with smart descriptions was to say, hey, we collect 8 pieces of information about every equipment lot that comes across. What if we doubled that? The value we could provide to our customers with better evaluations, better understanding of what features drive that equipment valuation, being able to look across technology. So like, if John Deere's got auto steer and then Case IH has another form, but it's a different brand name, right? And they have all these different technologies, all these different brand names. Now we can compare across OEMs and say, like, John Deere, your technology, no one's paying extra for it, but Case, they're paying extra for it. So maybe it's not that nobody wants it at John Deere, it's that the technology at John Deere doesn't work as well as the Case technology. Or maybe there's something about the Case customer that needs that technology more. Whatever it might be, we've just created that incredible insight saying that's a valuable piece of technology. For whatever reason, the green side, it's not working as well.
And I know you and I have talked about this, and I know a lot of the used equipment managers have talked about this too, especially on planters, right? And that's a beast of a project in and of itself, but they're like, you call all these pucks, all these row enhancement units, different things. Yeah. Some might do similar jobs, but one might be spoked wheels versus like even wheels. And there's so many nuances to that. Yes. And they have brand names to top it off. That makes it very difficult to put valuations on.
And it was difficult to train to that scenario because I had to say, hey, this downforce, they're all electric, but it might be called this, or this. And so we have to train the models to understand, like, there's different brand names and they've got, but they essentially have similar qualities. And so what are those qualities that we can kind of group on, and what sort of qualities are things that we can't group on? In the planner world, it was really difficult to do that training, but it's so worth it because, smart descriptions can turn through 10,000 lots in 20 minutes.
That's incredible. 'Cause we have million plus lots
Yes.
here at TractorZoom. And so if you can get through 10,000 lots in minutes, then, I mean, you're talking about, once you have that learning model set up, you could theoretically go through 1,000,000 models in a day.
Yes. Yeah, absolutely. And it's pennies on the dollar. When you have a person that has to go through and say, yep, it's got this thing, you can take 20 minutes, 30 minutes.
For one.
For one.
Mm-hmm.
And so, we're talking fractions of a penny per lot just to be able to get all of that information. Yeah. It's pretty stunning to and this is just the first iteration, we can continue to build on it, build a bigger data set and then continue to grow from here.
Okay. So that's if we take it from here and advance it, and I'm excited, and I'm going to ask you about what might be coming next. But you had posed a question to me that was, what would this world look like if we had AI from the beginning?
Yeah.
Right. And so I hope I'm phrasing that right, that, we've developed this incrementally along the way because we just really started kicking this into gear last year, 2 years ago. And so what if our dealerships, from the get-go had AI? How might things be different?
Yeah, I think it's really good to look at history here because this is another revolution in the way we work, right? I think they call it Industry 4.0 is a term that people throw around for, machines that talk to each other and AI and all that, and how that's going to change industry. So if you go and look at the steam engine, factories were built vertically. Factories were built vertically because that's where the steam shaft ran through. So all your equipment had to be attached vertically near the shaft going through the middle. When electricity rolled around, they just replaced the machines with electrical ones. But the factories were still vertical. It wasn't until Henry Ford and the processes he developed where you truly took advantage of electricity as if it existed all along, which is you have that assembly line process, long factories where everything just moved down all in one. And so that's what I'm kind of hinting at with the saying well, what would a process look like if we had it the whole time? Would you ever have used equipment inventory? Right? Because you should know, in theory, exactly what people want, when they want it, and who has it. And so you can just make that connection.
Right. Where it's at on all the farms, and then you kind of gauge people's receptiveness to be able to buy the next one.
Yeah.
They're connected.
Yeah.
Everything's connected. Interesting.
And then, we've got, I'm sure dealerships, they invest a ton in their service departments. In the future, what if any time a piece is about to break before it breaks, and you send out a tech to fix it before it's even broken? And that's not even that far-fetched.
Right.
The airline industry does do this. They have predictive maintenance, and they'll go and replace rotors in an engine before it breaks, before they need to replace it, but just before. And you can do the same thing, in agriculture. You're never going to know, hey, you ran into the barn door and broke something like that. But you're going to know if the transmission is going to go out. You're going to have all that machine data, and you're going to know all the history of all the other machines that are like it, running similar, fields, doing similar work. You're I know that transmission is going to go out in the next 2 weeks. I'm going to order that part, so you don't have inventory on parts. You're going to send that tech out and do the work right there. Which you just don't, it's not something that you can do right now, right? So we have to anticipate by ordering inventory of parts, which costs a bunch of money.
Holding those parts
causes factories to have to create a surplus, whereas factories could just be building them as needed, right? So then we could have a much more streamlined process to build the parts, deliver them to customers, and get it fixed.
Right. And even I know a big thing, for us in our farm, working with our dealership, is they want to connect us completely, and we're going down that path. But that's a huge benefit if this comes to reality of now all of a sudden I don't have to wait for parts when I break down. Hopefully, there's something there to predict when I will break down, so the part can be ready, delivered to me, and working on when I'm down because it's raining today, and swap out that bearing.
And it is a future vision. It's, to some people it might be that'll never happen, but we got there with electricity. And you can, as a farmer, if the dealership showed up at your door, be this needs to be replaced now, so you never have a day down.
Sold.
Yeah, you would be buying that equipment every time.
Right. Mm-hmm. Yeah, because time is money, and especially now in planting season, time is 100% money.
Yeah.
So it's one of those things where we won't get there individually. It's going to take a pretty massive movement from the industry, but it's where we can get to. And so some of those things of, man, do we do that? We only do this because it goes back to the rule thing. we just have all these rules in place because we just didn't know, we couldn't predict. But if you have a perfect prediction machine, what would that future look like?
Wow, that's crazy to think about. Okay, so a couple other things on, data science and improving processes. We had talked probably like 10, 15 minutes ago about technicians, because you and I were sitting here probably about 3-4 months ago and saying, how else might dealerships use this? And I think it had been a previous conference I was at where they're talking about technicians and the importance of writing down a good story of what you actually did.
Yeah.
And I think everybody listening to this knows that a technician's time is gold, right? I mean, the availability is tight and you've got great technicians. I don't really want to have my technician wasting time doing anything but fixing machines and, working billable hours and, working on that throughput. So do you want to kind of talk back to me on what we discussed when we were just hypothetically talking about how could AI data science help technicians within the dealership?
Yeah, and it goes beyond some of that, the monetary value too. Like if you're building an organization where you're having difficulties keeping top talent, top technicians, look at all the work that they don't like to do and try and find every possible solution to get that off their plate, right? All the bureaucracy, all the paperwork, no one wants to do that. And these technicians are super valuable. You want them to be happy. You want them working in your shop. So what can we do to get that stuff off their plate? And so the story, that we had talked about and that, I'd sort of kind of whiteboarded a solution to was when a customer goes in, gets a piece of equipment fixed, technician writes up a short story about, here's why it cost what it cost and here's why it took as long as it did. Customer gets it. Customer's like, I didn't think it would cost that much, or I didn't think that was wrong with it, and then starts to dispute the charges and dispute overall the work that was done. Well, that just takes everybody's time. It requires people at the front office talking with customers. You've got that customer management. If they're a big client, you obviously want to make sure they're happy. But then you've also got the technician just dealing with that back and forth, right? And it's also a skill, explaining at a level that anyone can understand, maybe all that technical work that you did. So people aren't necessarily trained on that. You probably don't go to tech school and learn about technical writing. I mean, that's not something that everyone learns. So it comes down to saying, hey, generative AI is great at telling stories. And you can actually kind of teach it to tell a story in the way that you want it to kind of speak the language, the tone, that sort of thing, to either for your brand, but also just to make sure that you're covering all you need from a compliance perspective, maybe under warranty. All those things can be taught to machine. And so technicians can probably just speak into their phone, say, here's what I did, here's how many hours it took. That goes into a generative AI model. It says, okay, I understand that, but I also understand the big picture. I also understand warranties and codes and everything else that goes into it. Let me turn that into a nice customer story that says, here's the work we did, here's why we did it. So here's, your bill at the end of the day, but you have that whole explanation leading up to it. And that would really just drive, customer satisfaction. They're not calling you, they're not upset. Your front office staff isn't dealing with difficult customers, angry customers, and technicians just have one more thing off their plate. They're just talking to their phone and they're moving on to the next thing.
Right, and it helps everybody on down the line. I mean, obviously it helps the farmer.
Yeah.
And then if you can increase your warranty claims, because now, like you mentioned, it's speaking the language and hitting, checking the boxes that need to be checked.
Yeah.
And even on the compliance person side on the warranty, when they're looking through that, it makes it easy for them too. And they're probably breezing through that and saying, okay, it checks these boxes. This is the work that was truly done. And it is the work that was done. You just don't have the inefficiencies of, transcribing data down, words down, and making sure that, looking up manuals and all that.
It's something is absolutely within reach. I think we've talked about, like, you need data. So you do need to have those customer stories that you've used in the past that work. You need to understand the warranty piece. You need to be able to train, the machine learning model on what needs to be said in terms of warranty perspective. But if you've got that, it really is just a little bit of elbow grease to make it happen.
Okay. So we had talked about, clean slate, started from the beginning and had AI all along. So, but we don't have that, right? From this point going forward, let's talk big picture right now. The more absurd, the better. Yeah. What kind of things do you think might even be possible out there with AI, data science, farm equipment, dealerships? It's a big question, but
I think the predictive maintenance piece for me is the most exciting. I think that I think that the way that that's going to trickle down into the factory level, into the OEM decisions, is going to be much larger than it may seem on the surface, because we know everything about all this equipment. We know exactly how it's going to break. Engineers are going to be able to design things on the fly better because they understand all the nuances of the way the machine's been used, how it's going to break. So like fixes, retrofits, that all is going to come faster. You're going to have your equipment up to speed, like you're not going to have to wait around for them to analyze anything or like run tests. It's all just going to be done. So engineers at factories will be much more efficient. Fixes will come out faster. And just the fact that like farmers are never going to have that downtime. And not never, but like it's going to be greatly reduced. And it's going to be things like, there's always going to be things out of your control. It's going to rain, tractor's going to get stuck.
Yeah, if you still run it,
Yeah.
it's still going to be there.
It's still going to be there, but you're not going to have that transmission go out on you.
So, in a previous life when I was an engineer as well, that we did a lot of predictive maintenance as well. And so I'm imagining when we did it, we were taking an ultrasound gun to a bearing, and then we're slowing it down by 1,000 so we could listen to every RPM of that. And then we could hear a gear if it was out, like click every second or so.
Yep.
So, but that took a sensor on a bearing.
Yes.
And then same thing with like heat. Like if we're looking at bearings overheating or engine block overheating, you have to have a sensor. So, we have to be able to have this data input somewhere from a machine. And ideally, it's not a manual or a visual inspection.
Right.
So do you think then that starts at the OEM level where we just have sensors all over the place that are just feeding in this information, and then it streams up to the cloud and back to the engineers?
So I think there's a couple ways you could approach that problem. And then one of them is not everything has all the sensors all the time, but you randomly test various pieces of machinery at all sorts of parts of their life cycle, so that you do have someone go up an ultrasound and listen to that click. And be like, I know all this information about this equipment. I know that I got to click, and I got to click 60% of the time. So now I can just go apply that same logic to all this other equipment in the field that I haven't tested. The other piece is looking at more of a higher level sensor. So there's always something causing that bearing to overheat, right? Can I have a sensor on maybe one step up in that system? So I don't have a sensor on every bearing, because that's crazy. But maybe that bearing's near an engine block. And maybe, that engine block, when it gets above a certain temperature for a certain period of time, that's what causes the bearing to wear. So now all I need to do is have a temperature measurement on the engine block or near an engine block. And then I can predict that bearing. So it's really looking at it more from a system level and understanding what's that one level up that I can actually have sensors on that apply to multiple, pieces below it. That's probably more of where I would imagine things would go. And then the thing that technology's improved so much is just like, we've always been able to put as many sensors as we want, for decades. But for the most part, it's just been like, and we can't do anything with that information. We just don't have the capacity to process that information. Well, now we do. So there's not a technology limit on terms of hardware and measuring things. It was always that, why would I pay that extra cost? Because I can't do anything with that information. Now, since we can do things with it, now that they do have those cloud data stores, now that you do have compute and generative AI and all of these things that kind of enable the leveraging that data, the value, the cost of putting those sensors in equipment now suddenly is worth it.
Interesting. Okay, so then let's bring it back from out in the field to kind of behind the screen and inner workings here at TractorZoom.
Yeah.
So smart descriptions, we've got that, and we're rolling it out. I know that we covered compact, subcompact tractors, sprayers, planters, and we're going to continue to roll that out across different categories.
Yeah.
For what you can tell me, what else is on the horizon at TractorZoom regarding TZ AI?
So one of the things that I obsess over is shortening the time between decision and action. Or insight and action, maybe the better way to phrase it. So a lot of times you'll go and you'll get your quarterly financial information, and then you'll go make a decision. At worst, you've just spent 3 months of waiting to get that insight to go take an action. How can I take that time and distance required to make an action and drive it essentially to zero? So with Anvil Pro, we actually are part of dealers' day-to-day process. Can I generate an insight for you about a customer? This customer is going to buy a piece of equipment, and here's that equipment. Now I've put those two things together, and I said, call them. So now your insight to decision is essentially a button that says call. And so now people aren't having to go to one system, understand the data, figure out, get that insight, and then go to a different system and take that action. We're really taking that decision insight, and driving it basically to one thing. That's one thing that I'm really excited about with the addition of Anvil Pro to the TractorZoom kind of family of solutions. The other thing too is that same sort of timeliness. We just don't have enough time and people to do all the things we need to do. So how can I make everyone's life more efficient by just using technology, using machine learning? So, you're going out into the field, evaluating a piece of equipment. It'd be great if you just took a picture of it, and then I filled out half the fields for you in terms of, hey, that's a John Deere S780, it's this year, it's got duals, and you just took a picture, and I filled all that stuff out for you. It's small things, but when each person doing that every day for months, like the amount of time saved can be pretty enormous by just making some of those small changes, but still improving processes.
Right.
So
that technology's out there right now. I mean, it's when I take a picture and flows up to Google Photos or whatever, I don't have to tag it to one certain kid or one certain event. I just go to Google Photo later and say, show me all the pictures of my son, and they're all there. Show me his birthday parties. All of them are there. It's crazy.
Yeah, 100%. Like the technology is there, and it goes back to the challenge. It's really the process that we've got to figure out. You take that picture, most of the time the picture's great. What if it's not? How do we tell the customer, hey, maybe go to the other side because you're staring straight into the sun? Right. And then, from the other side, we can take a picture. Or, hey, it's kind of blurry, or your finger's over the lens. But then, too, like allow them to still review the information and make sure it's accurate, because no prediction is 100% accurate. You may say, I want a picture of my son, but within Google Photos, maybe one of his friends makes it into that slideshow because they look similar, or they're both kids. So nothing's perfect. So it really comes down to that process piece too, of saying like, here's the information we think it has, making it easy for the user to validate. Just do a scan. Yep, good. And then if it isn't wrong, just quickly change it. So it's not right most of the time, but when it's wrong, it's a huge pain. It's right most of the time, and we've built a really nice process around it so that we know it can be wrong sometimes, and we made it easy for you to correct when needed.
Oh, and I know it's not exactly AI, but I know that's a big value that people find in the TractorZoom appraisal app. Yeah. Right. That it's a great app, but also it's a process that they can follow. It collects all the data cleanly and then puts it in there, but it's that process that guides the salesperson through there.
Yeah. No, it really does come down to that process piece of it, and then looking and identifying areas that AI can improve that process. Maybe change it drastically, maybe just a little bit, but at the end of the day, we're all just doing a process to do, to make something happen, and AI can be a great tool to improve those processes.
Oh, good. And then that's kind of a nice cap on it, because it brings it full circle from what you said just in the beginning, that what is AI? And you said it's this big bubble that encompasses a lot, but it's about processes within there, and then the people that actually use it.
People's important. People's the key. I mean, nothing happens without a person being involved, right? So if you can't get your team on board, if the processes, even if it's AI, but if those processes don't serve either your customers or your employees, you're not going to get any value out of it.
Okay. Fantastic. So a lot of my guests that have been on here, I've been asking them, other types of questions as well. And I know that a lot of people that, for instance, responded in the webinar saying, hey, I'm interested in AI. A lot of those were, data focused people at dealerships. Mm-hmm. So they might value a recommendation from you on books, for instance. And so, if you had to give a recommendation, or if you have to gift a book, what are some of your favorites?
So I might give you a little curveball here. I think the best thing that people can do is not technology. It's not very technology focused. Okay. It's really just changing your mindset. You have to get comfortable with a prediction that says I'm 80% confident. So it's the idea of weatherman says 80% chance of rain and it doesn't rain, and you're fine with it, because 20% of the time it's not going to rain.
Yeah, my dad's not fine with that.
Yeah, there's a lot of people that aren't, because if it's 80%, right, it's raining. It's going to rain today. Yep. And so one of the best books is a book called Thinking Fast and Slow.
Daniel Kahneman. One of my favorites.
It's a fantastic book. If you haven't read it, it's essentially, when is your gut right and when is your gut wrong? And all of those different biases we have. And so like he gave an example of chess. A grandmaster's gut instinct in chess is very accurate, because chess has a very defined set of rules, and the grandmaster's probably seen millions and millions of combinations. So even if that grandmaster can't tell you exactly why they know something is true, in a game of chess it probably is, because they've seen it, their brain has made all those connections, and they've got that gut instinct. On the opposite end of the spectrum is the stock market, where nobody can predict the future. And if anyone says they can, they're wrong. Essentially, it's just luck. People do win, but they're lucky because a lot of people, as many people, lose. And they're just unlucky. And there are very few people who can even game it a little bit. And so it's one of those things where you start to learn about all your biases that you have in the way you think, and getting comfortable with being uncomfortable is like, I just don't know and I can't know. Or here's the information I would need in order to know. And that sort of mindset, I think, is really required in order to be able to leverage data at scale. Because you're going to, at the end of the day, be like, the model is accurate, it's saying 80%, and I didn't win.
And being okay with that.
And I have to be okay with it.
Yep. Yeah, I would second that. It is by far my number one book as well. And it's a slower read. It's well written. It's a little tough to get. Yeah, because it is just, he is at a different level. And I know he passed just this past year, but he thinks way beyond what most people think, and is just so much intelligence every page.
That came out recently called Noise. So the first one is bias, and the second is noise is about variance. So the equation, most people probably don't know, error is the sum of bias and variance. So he's talking about the second piece of error, and variance would be things like, he had some fascinating study that you are more likely to be incarcerated in, say, for example, Philadelphia on a Monday if the Philadelphia Eagles lost than if they won, because the judge is a Philadelphia Eagles fan and he might be a little grumpy. Like, how much of our life is shaped by things like noise and chance and variance, and not just in a small way, in a very impactful way. Yep. And so that's another really great read. Again, it's also pretty heavy, but it just makes you realize how much we don't know. Pretty much everybody knows nothing about everything.
Absolutely don't.
Yes.
It's good for managers and data decision makers to read.
Yeah, and the one of the early books I read that kind of got me into the data space was Signal and the Noise by Nate Silver. So he's maybe he's gotten a little bit discolored with his political commentary, but he is a brilliant statistician and does great at prediction and predicting political outcomes from elections. And that book had a lot of just like, oh wow, I didn't know data could do X. I didn't know data could do Y. It has all these sorts of examples to help you understand the world a little bit different and how data can be useful in making decisions. And there's another one called Super Forecasters that's great, that just talks about people who have that ability to look at things so analytically. They're like 80% chance, that's right. And then the next day they learned a new piece of information and be like, now it's 82% because I learned this new piece of information. They're constantly updating their predictions. They're constantly learning and figuring things out. And they have that ability to constantly check themselves, which everyone struggles with. You always have that blind spot, but there's a specific group of people who have figured out a way to like cultivate a mindset where they don't really have these blind spots. And it's a really fascinating read, really cool stuff. Again, these are all kind of on the heavier side, but they're really interesting.
Yeah, definitely good to read. So good. Well, Hank, I appreciate you joining us on Beyond the Hood. Thanks for being here.
Pleasure.
Okay. And for our guests, please come back again and join us for another episode of Beyond the Hood.
Thank you for joining us in this episode of Beyond the Hood with TractorZoom and our interview with Hank Mandsager, lead data scientist at TractorZoom. Please take a moment to like, follow, and subscribe to this podcast in your favorite podcasting channels. If you're intrigued in what Hank had to talk about and how TractorZoom is partnering with our dealers, make sure you to reach out to us at TractorZoomPro.com. You can also find some of our contact information in the show notes. We look forward to continuing this conversation with you as we look beyond the hood in future episodes. Take care.